Welcome to the 6GSymposium. My name is Szporer, and I'm an editor and writer at 6gworld.com. I'll be the moderator of this panel discussion on verticals-centric network operations. Before we begin, let me just shamelessly plug 6G World if you'll allow me. 6G World is a forum for news, debates, research, and ideas to help the telecom sector, academia, and governments bridge the early days of 5G as it continues to roll out to the end of the decade. That's, of course, the projected launch point of 6G, which is the reason we're all here today. More specifically speaking, we're here to find out more about networks and how their operations are poised to vary with respect to different vertical sectors. Major mobile network operators have tended to focus their attention on mass market B2C models. However, there are more and more signs of B2B models emerging too, ones featuring services like network slicing and ultra-reliable low-latency communications, URLLC. MNOs ultimately are poised to adapt their service offerings to cater to individual vertical sectors with increasing frequency. With that in mind, we're incredibly fortunate to have with us a panel of experts spanning a wide cross-section of sectors with the goal of presenting different perspectives on network operations and requirements moving forward. Joining us today are Stephen Carlini, Vice President of Innovation and Data Center at Schneider Electric, Sylvia, Head of Technology Strategy at u-blox and board member at 5G Alliance for Connected Industries and Automation, Tommaso, Melodia, Director of the Institute for the Wireless Internet of Things at Northeastern University, and Patrick Waldemar, Vice President and Head of Technology at Telenor Research, a part of Telenor Group. I will first ask each of our panelists to introduce themselves and present their takes on the subject at hand based on their work, personal thoughts, and experiences. From there, we'll move on to a Q&A period, during which we hope to get to the audience questions, all to help build up the conversation and explore the ever-shifting landscape in front of us. The Q&A period will be structured essentially as a conversation, and we would love your input. So please share your thoughts and questions as we go. You'll find a Q&A button under the video feed. Please don't be shy about using it. I will do my best to get to every audience question. However, because time is finite, I may not be able to. In such an instance, we'll try to follow up with audience members whose questions didn't get answered in the coming days. I'm sure everyone will be taking notes throughout the different presentations and discussion, but in case you missed something, we'll be making a recording available on the 6G World website in the coming days. Please feel free to drop by again and rewatch the discussion, and maybe read a story or two while you're at it. So hopefully the foundation has been adequately laid for the next hour and a half. Patrick, would you like to start us off by introducing yourself, your role at Telenor Research, and how you see the evolution from 4G all the way to 6G?
Thank you, Ryan. I'd love to do that. So my name is Patrick Waldemar. I have been with Telenor since 2002. And prior to that, I worked in research and innovation at Statoil, now Equinor, and also at Fast Search and Transfer, a software development company. So I really have passion for working across sectors. I really have passion for trying to make the most out of both technology and business. And I'm looking forward to sharing my view on vertical-centric network operations with you today. So next page, please. So before I start on my view, let me just give you a short introduction to the Telenor Group. Telenor was established in 1855, more than 165 years ago. And since 1967, we've had a very active research organization. Telenor is a global company with 4 business units in the Nordics and 5 business units in Asia. And at the end of last year, I think we had 182 million mobile subscribers. So please go to the next page. You know, over the last years, and with this, every 10th year, there's a change in generation. We see new shifts and new focuses in each of the mobile generations. And when we're now started looking into 6G, I would like to take you through this and go through that. We have seen the shift from analog to digital voice, into mobile data, into mobile broadband. When we come to the 5th generation, you can debate, is it about extreme speed, industrial IoT, the network society, tactile internet, or the wireless edge? I would say all of these are enablers, but they are important for the solutions that can be used for vertical industries. So verticals are the most prominent 5G shift and the focus of 5G. And what we will see as the various generations evolve is that also the performance, the functionality, and the features get richer. And when we're starting moving into 6G, we can realize that with 5G, we've had an evolution of the network architecture where you have a tight convergence of the IT and telco domains. Whereas when we start to move towards 6G, I expect to build on top of this and bring a lot of features like AI-based automation, high-performance computing, and access to various technologies that would enable a near-instant and unrestricted complete wireless connectivity. So that's the setting that we are looking into when we are diving into this. If you go to the next page, please. The one thing that enables us to serve multiple industry and multiple industry verticals and their needs is network slicing. And network slicing serves us by enabling operational and performance requirements from various industries. It could be from factories of the future, like shown here, like e-health or automotive. Even though at the bottom there is a physical infrastructure, you will have logical networks that can serve the various requirements from these sectors. Network slicing is designed to support these verticals by the different requirements. And driven by and customized by the verticals, the 5G deployments are deployed in close collaboration with the verticals. I expect that when we see and move into 6G, we will need to improve our ability to test and operate the verticals and network services and the way we are enabling the new innovations. Please go to the next slide, please. In order to take a look at 6G, I would like to just outline how I see the business of 5G. The business of 5G starts with consumer mobile broadband. It starts with an evolution from 4G, making use of the enhanced mobile broadband slice. Then it moves into solutions for IoT when we're using the massive IoT slice, which is naturally serving both consumer customers and industrial use cases. Then we come to mission critical communication using the ultra reliable low latency slice. And this one is serving both industrial critical infrastructures and governmental critical infrastructures. In all of these various business parts of 5G, there is a need for efficient operation and automation. And in particular for the IoT and mission critical communication, there will be a need for more vertical-centric network operations. Please go to the next slide, please. So, as an introduction to the coming Q&A session, I would like to share with you my view of the 6G vision and my understanding of the innovation areas that is needed to ensure a vertical-centric network operations. When we're looking into the 6G vision, we know that there is a growing demand for new services and there is a predicted growth for new technologies over the next decade. And in my view, the 6G networks are expected to deliver improved connectivity that satisfy the evolution of these services and applications, and that makes them an enabler for the intelligent knowledge society of 2030. Moreover, I do think 6G will link everything, provide improved wireless coverage, and deliver an efficient and highly valuable connectivity by combining the features such as sensing, computing, caching, monitoring, positioning, radar, navigation, and imaging in order to enable these new vertical applications. However, this will not be possible unless we do a lot of work within several innovation areas. And cross-sector collaboration is really needed to understand the various needs and to start this off in the correct manner. Then we need sandbox environments, test platforms that can enable cross-industrial innovations and improve the vertical-centric network operations. And finally, we need to improve our deployment frameworks so that we can address the requirements from the verticals within service performance, within functionality, within the topology, and for the value-added services. So my final words in this introduction will be that the main principles for our future mobile communications should have the ability to handle a higher degree of flexibility and functionality. And this will enable 6G to support the new use cases with special networks for the various industry verticals. So with this, I hand it over to the next introduction. Thank you.
Thank you, Patrick. Tommaso is next up, and among other topics, will be presenting on unmanned aerial vehicle use cases. Tommaso.
Good morning or afternoon, depending on what part of the world, mostly good afternoon, I would say. I'm Tommaso Melodia. I'm a professor of electrical and computer engineering at Northeastern University in Boston. I'm also the director of the Institute for the Wireless Internet of Things. And I'm going to talk about primarily the nexus between vertical-centric operations and advanced network control as enabled by open and programmable network architectures that will characterize 6G systems. Next slide, please. So the next generation of wireless systems will need to support diverse and vertically integrated use cases. And I believe this will be to a different extent than 5G networks currently deployed are able to do today. So one-size-fits-all architectures will not be really sufficient for that, and we'll need new flexible and programmable wireless network architectures to enable all the services, the vertical integrated services that will characterize the future of 6G systems. Next slide, please. So what's happening? This is already happening today, right? With the evolution towards open, programmable, and virtualized next-G systems. We're moving from black box architectures where all the functionalities are implemented in hardware on a base station or close to a base station, and to an architecture that is open, programmable, and virtualized, right? Virtualized because all the components are moving to the cloud. Open because they're connected through open and standardized interfaces. And it's programmable because it exposes a centralized and abstract view of the network through a set of abstractions that are exposed through the so-called RAN intelligent controller, or RIC. You see here on the left of this diagram, the black box, right? And this enables implementing intelligent control loops that are going to be crucial to deploy vertically integrated use cases. Next slide, please. All right, so, and my computer is not advancing, so. All right, so what this movement towards open architecture has been led by several different standardization bodies and consortia. The ORAN architecture that you see here is characterized by flexibility by design and dynamic network control that is enabled through open interfaces and APIs, and by the introduction of the RAN intelligent controller. You see a near real-time RAN intelligent controller that is in charge of operations that have timescales in the order of a few milliseconds, and a non-real-time RAN intelligent controller, or RIC, that is in charge of operations that have timescales in the order of seconds. This provides an abstraction of the network that allows telecom operators to implement third-party custom control logic that can be specialized for specific architecture, for specific use cases. Next slide, please. So through these centralized network control abstractions that are exposed by the RIC, we can implement application-specific and vertically integrated controllers that can control the network functionalities through software by observing the performance, but also inconsistent behaviors or anomalies, and automatically reconfigure the functionalities in an application-dependent way to obtain specific objectives through software control applications, the so-called XApps. And again, this can be application-dependent. Next slide, please. So this table shows some of the control loops that can be implemented through open architectures and run intelligent controller. They differ in terms of the functionalities that are controlled, the scale, the input data, and the time scale at which they operate. For example, we can control with a loop between the non-real-time RIC and the near real-time RIC functionalities like policies, slicing, that have scales of tens of thousands of devices and that have time scales of operation in the order of a few seconds. But also by creating loops between the near real-time RIC and the CU component of the G0B, we can control functionalities like load balancing that have scales of the order of hundreds of devices that are near real time, or even with control loops within the near real-time RIC and the DU, we can control functionalities like scheduling, policy, etc. Right? Next slide, please. So clearly, intelligent control and virtualization are also connected with the theme of radio access network slicing, which is the idea of sharing a common network infrastructure between different orthogonal, isolated, and virtualized networks that can, for example, although they don't need to, belong to different virtual network operators. There is typically a slice request component, which is followed by a slice assignment component where the infrastructure assigns portions of the physical infrastructure to different mobile virtual network operator. And then maybe a less understood component, which we like to call the slice enforcement component, which determines what physical resources should be assigned to each slice to guarantee isolation with either slice and really higher performance of the run. And then the scheduling and transmission on each individual slice. Now, clearly, slicing and intelligent resource allocation have a very close relationship, and they're going to be crucial in our capability to support different use cases, vertically integrated use cases. Just an example here, think about a system where you have different vertically integrated applications that require different resources. For example, in terms of communication, computation, storage, and it have very different characteristics. You can think of machine type traffic slice coexisting with a URLLC slice, ultra reliable low latency slice, and then enhanced mobile broadband slice, right? And then you're going to have intelligent scheduling to for each run slice, and the sites and the physical resources allocated to each run slice can vary with time to keep track of the variations in the traffic patterns, mobility, etc. Right? So by exploiting data-driven close control loop with the near real-time RIC, we want to automatically tune the radio access network parameters for each individual slice and do that in an intelligent way in real time. We've implemented the prototype of a system that does that. Like if you can move to the next slide. On the, actually, sorry, next slide. On the Colosseum. Colosseum is the world's largest wireless network emulator with granularity at the radio frequency signal level. This is something that was originally developed by DARPA for the Spectrum Collaboration Challenge, and that with support from the National Science Foundation moved to Northeastern at the end of last year. It's a massive system with 256 programmable radios, a lot of computing resources, CPUs, GPUs, and the capability to instantiate fully virtualized wireless systems. Next slide, please. So on Colosseum, we implemented the prototype of system that I described before, intelligent RAN slicing and scheduling, where we have an environment model in the Colosseum in the emulator that includes 4 fully virtualized base stations, each one with 3 different slices with different kinds of traffic that I described earlier, and with 10 different users. Each one is running a fully virtualized, each base station is implemented with the SRS-LTE software, and similarly the UEs are implemented with SRS-LTE software. And we implemented an ORAN compliant, or for the most part, ORAN compliant RAN intelligent controller that runs in parallel 12 deep reinforcement learning agents implemented through fully connected neural networks that provide online inference and real-time control of the various slices and the scheduling policies on each slice. They've been trained offline with 6 GB of data, 63 hours of experiments, and they provide decisions on the scheduling policies for each base station slice, selecting the scheduling policy between various different options. And we've been able to show, we have recent publications on this, significantly improved spectral efficiency for mobile broadband users, as well as satisfying URLLC user requests and reducing significantly the buffer occupancy. If you move to the next slide, I believe that the combination of real-time control and virtualized architectures will enable a number of exciting scenarios. Think of verticals with drones, like the application scenarios that are being considered today by the Open Generation Consortium. The AirPow platform within the NSF Platforms for Advanced Wireless Research Program is a testing platform with fully programmable radios and use cases for drones that can enable a number of the application scenarios and a number of the testing with real-time closed-loop control systems that I described today at the intersection between open wireless architectures and drones. And if you move to the next slide, I'm going to conclude with saying basically the future networks will be open, programmable, and virtualized, and the ability to create close control loops between the analytics that are exposed by the open architectures and the real-time control enabled by algorithmic innovation in the RAN will enable vertical integrated use cases like we're describing today. Thank you.
Thank you, Tommaso. Sylvia, the floor is now yours to discuss industrial IoT and the projected evolution of connectivity.
Thank you, Ryan, and hello, everyone. So in the next couple of slides, I will cover cellular connectivity evolution roadmap, the key enablers, general evolution trends, and then we will have a look specifically at the industrial vertical with my 5G ECI hats on. And I'll also share some example key aspects to consider from this vertical in the beyond 5G 6G era in terms of vision and requirements definition stage. So here I am, head of technology strategy at u-blox, actually 14 years in the telecom industry, fortunately enough to have worked on 4 mobile generations from even the 2G days, and mostly with the chipset vendors. So I will also share some perspective from the device side. Before I dive into the next slide, just a brief mention to u-blox. We are a Swiss module and chipset vendor. There are about 1 billion people globally using our products and services every day to enable localization, cellular and short-range connectivity and services in the automotive, industrial, and consumer markets. So just to set some backgrounds. Now let's start with a quick overview and high-level overview here on the cellular connectivity evolution trends. There are 3 key trends I'd like to highlight. First of all, there are at least 3 threads evolving in parallel under the umbrella of 5G in the past 3 years. So that's at the top, high-end mobile broadband evolution. And at the low end, we have LPWA evolution, that's low power, wide area technologies like LTE-M and Narrowband IoT for smart meter sensors, which demand long battery life and low device cost. I will come back to the 3rd thread in the middle in a second, but it's worth highlighting here that reflecting from the past evolution trends, especially from the perspective of the device side, there are at least the differentiation of these high and low end devices that are evolving in parallel. And I bet these parallel threads will continue their courses in the 6G era. So it's important to highlight here that it's not just about the high-end devices that can work in terahertz with super low latency, which are really important, but there are also this IoT ecology, if you like, that I like to call the name of ecology that benefits most from smaller device form factor, longer battery life, and lower energy consumptions. And it's that ecology provides one of the fundamental building blocks for sensing, twinning, as has been mentioned in the 6G vision session this morning, and also by one of the panelists just now. Now, back to the third thread between the lines here, that's when it becomes interesting. If we look at the 5G era, which is the second key trend here, is the different flavors of 5G to enable connectivities for industries beyond the consumer sector. So we got cellular-based V2X for automotive sector to enable connectivity between cars, infrastructures, or pedestrians. And our new radio industrial IoT to enable ultra-low latency and reliable communications for the smart factories, and satellite-based IoT to enable direct communications from the satellites at LEO and GEO constellation directly to LPA devices. So in terms of second key trend, as you can see in the 5G era, it's not just the three famous pillars, but there are at least 8 technology components under the umbrella of 5G. It is more than incremental, and the 5G technology landscape is much more complex, as you can see here. And this certainly brings another layer of complexity, at least from the device side. Obviously, it's just not practical to support all these flavors in a single chipset or module. So there's not a silly bullet point solution for all, also from the device side. Another point I'd like to mention that the 5G device commercial availability timeline is different for those different flavors. And this in some way created the initial supply shortage, if you like, for the 5G UR/ARC devices, for example, because simply the standards took a phased approach to deliver eMBB first, which is important and practical, and then UR/ARC, etc. So we've seen that industrial trials cannot really test properly the low latency features on day one when 5G was introduced. So this is perhaps something to think about on how we can make the next generation devices more accessible for early trials to cover as many vertical sectors as possible in terms of encouraging, inviting adoption. So just to summarize on this slide, we can already see in the 5G era, it's not just about one thing, but it has several different flavors with capabilities ranging from low to high, with different flavors in between. And this is fundamentally important for device vendors to understand this landscape. And it's safe to predict here that 6G will follow the same trends of these multiple threads with different capabilities. And obviously 5G is not done yet, still lots to come in 3GPP, at least in the next 5 years, and the development will continue for at least the next 10 years. Now I'll move to the next slide. With those new capabilities, as mentioned before, it is indeed helping to expand connectivity beyond the consumer sector. It's no longer B2C, as Ryan mentioned earlier, but also B2B, to enable new products and services into the automotive, manufacturing, and process industries, ports, maritime, media creative sector, satellites, and utility sector, just to name a few. And we expect this expansion will continue to follow in the 5G, beyond 5G and 6G era. Now, for the next couple of slides, I will focus on the industry vertical with my 5G ECR hats on, in particular the manufacturing process industry, and I will share some early thoughts on the key aspect to consider. I want to first of all to give some background about 5G ECI. As we heard this morning from the General Chair of 5G ECI, Andreas Müller, that 5G ECI was established back in 2018 with a mission to enabling the full potential of 5G technology in connected industries to further advance Industry 4.0. And to achieve that, we bring the entire industry 5G ecosystem together now with around 85 members worldwide to really ensure that the need and requirements of the industrial automation sectors are adequately considered, for example, in standardization and regulation process. And also importantly, to really ensure that a seamless and easy integration of 5G into the existing industrial infrastructure and application is possible. Now, with the fourth industrial evolution still ongoing and will continue its course for the next decades, and the fact, as mentioned this morning, that the lifespan of the industrial infrastructure and equipment lasts for at least 20 or even 30 years. So ultimately, really, during this timeline of the fourth industrial revolution, we will encounter at least 2 mobile generations or even more. And in some cases, it may even need to leverage 4G as a fallback or for coverage. So in that sense, 5G ECI will continue to bring forward requirements to the relevant standardization bodies to make sure the long-term success of the mobile communication, in particular in the industrial vertical sector. Now I'll give some in the next couple of slides, I'll give some thoughts on some example industrial requirements that need to be considered in the next decade. So here are some example key enablers to consider. First and foremost, key requirement on backwards compatibility in line with the long lifetime of industrial infrastructures and equipment. As we've seen in the previous slide, 5G networks has just recently started being deployed. So we want to protect the investment of the industry in 5G technology in future evolution of standards and the following generations. So that's very clear. And now starting from left, strengthening of a non-public network. So now we know that the different deployment models of MPN opened new opportunities for business model innovation, especially for the manufacturing industry. And we expect to see further activities around this domain to advance the development of MPN and the associated flexible development and operating models as well. The next one is sophisticated self-management capability. We've seen the trend of flexible production system, shorter and more efficient engineering phases. So these lead to a higher demand, if you like, for wireless connections. But at the same time, they are also craving for more energy efficient and cost efficient solutions to provide services for much higher number of reliable connections. So a sophisticated self-management capability based on network automation and AI ML is crucial, which also been mentioned by my panelists. So that network can intelligently and automatically adapt to the changing conditions. It also means the long term to also speed up the adoption of green technologies, also to boost sustainability, which is also important. We also need flexible and modular solutions to help to support customer tailored, energy efficient and cost efficient deployment. And a further evolution of open interface architecture. This is because the manufacturing sector is fragmented with many standards, applications and constraints. But of course, also the demand side is looking for tailored and optimized solutions for different scenarios. But this can be enabled by really opening up the interfaces, the truly open interface, if you like, scalable architecture and API, in that way could help to facilitate this highly modular and industrial optimized solution. And last but not least, supporting requirements such as high precision positioning for indoor environment, and as well as high precision time sync in places where GNSS is not available. So, so there's lots to consider, but of course, the thoughts on that will be evolving as we have more insights about the evolution, technology evolution in 3GPP or the other organizations as well. Now, moving to the next couple of slides, just to give a background on the number of members that are currently participating in 5G CIA. So everyone's welcome to contribute and really to drive the direction of travel, how it should incorporate your requirements in the next standardization or technology evolution phase. And then the last slide, really to conclude that you would find several updated latest white papers on 5G ECI website, give a general overview on various different topics on TSN, digital twins, exposure interface, security, and performance testing. So, so here's a link for those who are interested. And with that, thank you very much, Ryan.
Thank you, Sylvia. I'd like to remind the audience that you can please send in your questions and we'll get to them at the end of the presentations. And now I'd like to give Stephen the opportunity to bring us home with his presentation on futuristic applications, both in general and data center setting in the future.
Thank you. I'm Stephen Carlini. I'm the Vice President of Innovation at Schneider Electric. I wanted to start by saying that Sylvia mentioned we are one of the companies that was in the 5G ACIA members, and we are very, very much in favor of open interfaces and factory automation. For this presentation, I'm going to talk about 5G and 6G applications. I'm a member of the World Economic Forum 5G network. We've been talking about this quite a lot, and we've published some material on it. I'm also going to talk about the impact of data centers. I originally started talking about data center physical infrastructure at the edge 5 or 6 years ago, and then we started seeing the merger of IT and telco networks and the deployment at the edge happening at the same time. So started putting it all together. I've been talking about 5G from a data center perspective now for about 3 years, and very excited about the possibilities with 5G and now 6G coming in the next decade. So next slide, please. So some of the this slide I've been presenting for a long time, and we're going to talk about high band millimeter wave 5G, not low band 5G. And my presentation is a little bit of a higher level of abstraction than some of the other presentations. One of the applications, I was in the hospital a few weeks ago getting my J&J COVID shot, and they were celebrating their 1,000th robotic surgery in the hospital that I was in at the time I was in. So very exciting. So you are starting to see some of these applications popping up and actually becoming mainstream. With 5G and with ultra reliable, low latency, high band 5G, everyone wants to talk about holograms, the virtual reality, the immersive experience. These things are, still very much possible with 5G. It's going to take an incredible investment in, the global infrastructure for 5G to make that happen. Haptic technology, the ability to feel, communicate, and adding feeling to the experience is another thing that's possible with 5G. 5G has been kind of the promise, and it is starting. We are starting to see some applications roll out. You go to the next slide, please. But one of the barriers of 5G and some of the things we talked about, one of the barriers to the tactile internet, one of the presenters talked about, is the speed of light. You still have this thing that you have to deal with called physics. And physics, and when we talk about robotic surgeries, most of the robotic surgeries that are done are actually done by a doctor that's on site. So they're using the robot, for other other advantages, like the ability to, with strength, ability to cut bones, break bones very, very quickly that you couldn't, usually do with your hands. The idea that you can have one surgeon operating from one side of the country to the other. In this case, we're talking about, we have a picture of the US here. This is about 4,500 miles, about 7,000 kilometers. So best case with the speed of light, you're talking about 40 milliseconds of speed to send data to and from. But that's theoretical. So that's a massless particle. When you're talking about real data actually does have, microscopic weight, but it does have weight. And fiber optic communications does not go straight through. It actually bounces off the sides of the cable. So the actual best case of communications from one side, of the US to another is actually 90 milliseconds. So you have a bit of lag in there. So doing things in real time is problematic. That's why when we talk about 5G and when we're talking about 6G, we're going to be talking about areas or pockets or clusters or communities, whatever you want to call them, of smaller areas where you're going to have, real-time types of communication of less than 10 milliseconds, or with 6G less than 1 millisecond. So keep that in mind, that we are being held back a little bit by physics. And with this actually, on the next slide, you'll show that we actually need a data center architecture that involves a lot of what we call MECs, or mobile edge compute, or edge computing, or multi-axis edge computing. These are the computing devices that are in the small clusters. Stadiums, we thought, well, that would be a great test bed for 5G applications. And still to this day, I thought it was going to be more of a test bed, but it's turning into a real application. And Tommaso even showed the Coliseum was an actual deployment of 5G technology. So why are those good deployments? Because the radio access network really needs line of sight types of communication, and you need an extensive RAN. So you need these physical antennas, and because of the higher frequencies, they don't go as far. So you need this huge network of these radio antennas. In the Coliseum example, I think there was 4 base stations. On the one I showed us, it's 5. But there are applications springing up for 5G on the manufacturing side. You're starting to see 5G being used in quality control. You're starting to see high definition video replacing some of the old antiquated. You're seeing it to look at high definition video, looking at machine wear and report back. So not the sexiest applications, not robotic process automation and untethering the robots, but that's an application. As Sylvia was presenting, these things take a while to cycle through. And with 5G, you are going to be able to untether robots, have the robots communicate with each other through Industry 4.0, and 5G is going to be the preferred communication for that. You have Wi-Fi 6 and some of these other applications, but Wi-Fi 6 isn't a communication, isn't a communication standard that is 100% stable and consistent. 5G is, because of beamforming and also sharing the signal between the different antennas. It's an absolutely solid communication. You're also seeing trials and things like smart cities and public transport. You're seeing smart ambulances in the UK, for example. And smart ambulances, there's multiple functions. They have high definition video, so they can broadcast back to the hospital, to a doctor, and perform some kind of preventative measures that they may not be able to do without the doctor on call being able to see it. Also, they can clear the way for traffic. So things like this are starting to pop up. With COVID, you're starting to see more and more 5G applications in the contactless, touch-free world for crowd management and public communications as well. So next slide, please. So 6G, so terahertz communication. So this takes everything to the next level. We talked about 5G, being able to, extend the sense to touch. We're talking about multi-sensory extended reality. So all 5 senses: sight, hearing, touch, taste, and smell. So zero latency really opens up more applications. This idea of BCI, of brain to computer interface, is an interesting one. So what this is things like using your brain waves to control things like robotic prosthetics, for example. So you could have, you know, a new leg or a new hand or something like that that's actually controlled through your brain. So this is actually, you know, blows people's minds when they start thinking about the things that we're talking about with 6G and all the concerns. I'm not saying I endorse or Schneider endorses any of these applications, but the idea that, you know, you're going to embed things that, you know, into your body that you used to, you know, be part of your phone. You're in the future, we're talking about not being tethered, you know, by your phone anymore. You're going to look at your phone as more of an antique that you used to carry around, that you're not going to need it anymore, because everything's going to communicate, you know, directly to, you know, the infrastructure that you have, you know, on your body. The other thing that was different about 5G is this idea of these mesh networks. And we talked about the RAN that you need for 5G and all the antennas that you're going to need. In 6G, because of the frequencies, everything that communicates is going to be a two-way communication. So it's going to be input and output. So everywhere you go, the environments that you go in, all the devices are not just going to act as, you know, control devices. They're also going to act as radio antennas to communicate and build up this big mesh network. So go to the next slide, please. So this is just what it shows. Like, so you're going to have this entire mesh networks. So all these devices that are communicating for all the different applications, you're still going to need these mobile edge compute data centers everywhere. So you're going to have these little clusters of 6G communication, but they all have to be processed by a local MEC data center, like I talked about, because of the speed of light. So you're going to have lots of deployments of these MEC data centers, and I think some of the other presenters were talking about it, that 6G will probably be a build out on the 5G. So the MEC data centers with 5G, the software and hardware is disaggregated. So it's a software defined application. So as 5G evolves, as more things with, you know, having to do with the 5G functionality, network slicing, and all of the other functions of 5G, that could be dynamically upgraded. And as we move from 5G to 6G, the idea is that those same MEC data centers are still going to be used. So these data centers are going to have to be everywhere. They're going to be in tops of buildings. They're going to be in basements. They're going to be in car parks. They're going to be all over the place in the 5G world and the 6G world. So next slide, please. And 5G, I think this was an early example of 5G, but it was very, very futuristic. This was Ender's Game, where he actually fights a war using his voice and motions. And he thought he was, you know, engaging in a training mission, but it was an actual war he was fighting against a different race. So it was, you know, an example of what's possible. But even this, you know, even the idea that you're going to be using gestures and voice, you know, in the future with 6G, it's going to really push the limits of this and the automation that you're going to be able to do, you know, basically just by thinking about it with 6G. So thank you. That was my presentation.
Thank you, Stephen. So I see we have a few audience questions. Before we get to those, I'd just like to get the ball rolling with a few of my own. Using slicing as just one example, how do you see operators catering to the network requirements of their customers in different sectors as the 5G continues to evolve? Tommaso, would you be able to take that one?
I'll take a shot at that, Ryan. Thanks for the question. So I think essentially there are three major macro knobs, let's call them. One is slicing, for sure, slicing and slicing done right with the right allocation of physical resources to different virtual slices is definitely a powerful tool for the network operator to provide services. Within each individual slice and across slices, intelligent resource allocation as enabled by advanced AI algorithms, and also, you know, more traditional algorithmic development is another important knob. And there's a number of things that can be controlled, including the scheduling policies, allocation of resources at the lower level of the protocol stack that are extremely important. And the third knob, I would say, is the capability to orchestrate resources on larger time scales across the network, right? So providing services for specific vertical use cases requires allocation of communication functionalities, but also of computation functionalities and storage functionalities. And large-scale orchestration as enabled by AI algorithms in real time of virtualized resources for computation, communication, and storage is going to be crucial going forward.
Thank you. Does anyone have any other thoughts? Okay. Sorry, Patrick.
Yes, just even now, what we're doing when we are working with the verticals is a lot about understanding their needs and to some extent co-creating the services and understanding how we can enable each vertical to be efficient in their use. So in my head, it's about operational efficiency, and it's about being able to automate the network both for ourselves as a mobile operator, but also for each of the verticals.
Awesome. So I've got another question. Let's start with Patrick. How do you think preferences between network slices and, say, private networks will vary between sectors?
Well, a network slice enables targeted solutions, and the various sectors will use this either in a private network or as part of a public mobile network. So I guess what you're asking is more about whether we can expect some sectors to be more active in establishing their own private networks or using the common slices. And I do think that this will vary from country to country, because we will see that this is also dependent on the regulations and the spectrum availabilities. And I do think that there will be an increased use of 5G technology for private networks, and that we will see that this will vary and develop a little bit different from country to country and from customer to customer. However, we already see, that for hospital network, for instance, in the defense case, or for automation in the industry, there is a lot of needs for private networks, and it can be solved either with specific private networks or as a part of the general available slice or a dedicated slice from the mobile operators.
Great. Before I get to audience questions, does anyone have anything to add to that? Okay. So the first audience question. Implementing 5G in industries by following the URLC capacity and massive connectivity could lead to resiliency sacrificing. More specifically, in medical applications, the resiliency is a very narrow connection to safety and risk assessments. What will be the 6G resolutions on resiliency, or more specifically, EMI resiliency?
I'm Patrick here again. I'm not really sure whether I will have the answer, but when we've been working with hospitals quite a lot. It's about understanding their needs for their specific application and also understanding what is special for typical machinery. And here you're talking about the resiliency towards the electromagnetic part, and that is in my head just one thing that you would need to treat special. And as such, I don't think that it will be solved particularly by 6G, but it will be solved in the case for working with medical solutions.
Thank you. Next question, unless anyone has anything to add. How dependent are the carriers on consumers for cash? Could a lack of consumer adoption hinder investment on supporting industrial applications? Anybody?
Well, being the mobile operator, I can at least say that, you know, there is a mix of rolling out and having the large scale consumer services, and over the years that has been the main source. And now when we start working with the industrial solutions, you are working to find the best business models. So before this scales and before we are in this open competition, there will be a development where you understand the various sectors and you scale either sector by sector or by reusing your solutions across sectors.
Yeah, that's a good point. That's how we're seeing it. We're seeing a rollout by industries, and specifically in industrial applications seems to be one where, you know, you could deploy a private network, you know, with 4.5G or 5G, as people were talking about, and upgrade it to 6G. But industrial applications in specific are very much an area where we are seeing investments being made. And like I said, it's not the sexiest investments, but it is, you know, on the maintenance side of things, we're starting to see applications emerge, and on the quality control, as I mentioned earlier. So we'll start with those, and then you get into, you know, more advanced Industry 4.0 applications.
Thank you, Stephen. So this is a question specifically for Sylvia. It looks like for verticals, there is a need for optimized chip/modules rather than one fit all. How do you see the economics of developing those optimized chips/modules for the vertical applications?
Yeah, thank you, Sona, for the question. So that's why it's really important for standards to have this key role of not really to encourage further fragmentation of the market. We've already have these fundamental 3 pillars, and in the future, in the next year half, we will see another flavor coming, for example, red cap. So I think in the past couple of months, the 3GPP did a really good job not to further fragment this by saying we actually want one device type. I think this is one example how standards, 3GPP, could really leverage this successful channel to really find the common voice from the manufacturing sectors or different sectors, get their inputs, and not to encourage further fragmentation of the market. Because at the end of the day, when you have so many different devices with different capabilities, that also add complexity at the network management level in terms of slicing different service levels. So for the benefit for industry, I think we should think carefully when we introduce new device types, not for the sake of technology innovation, but really find the real market and the demand for taking those new technologies.
Thank you, Sylvia. So we've got a brain-computer interface question, if anyone is willing to tackle that. How does BCI work? Does the terahertz connectivity fit the best with BCI regarding the EMF exposure? Can anyone venture a guess?
I don't have the answer to that one. So.
All right.
I think if anybody had the answer, that would be a very nice business. But I don't. I think that there's quite a bit of work ongoing in that space. Terahertz certainly will have the bandwidth and potentially the latency to transmit that information real fast. The vast amount of information generated by the brain. It needs to be seen whether you are able to transmit close to the brain at powers that are low enough to and not create heating of the tissues, you can't increase the temperature of the brain. So there's a number of alternatives that are being studied to that, including using ultrasound and things like that. But that's a very interesting area.
I guess this is a question for Patrick. Telenor is in a diverse market ranging from Norway to Southeast Asia. What are current demands and pressures because this predicts future?
I'm not 100% sure if I understand the question, but Telenor as a group has evolved from the Nordics and working in Asia, having been there several years. A lot of what we have managed to do is to scale from one business unit to another one. And when it comes to demand, you know, it's been a demand for broadband connectivity mostly, and now we see a shift towards more industrial demands. So that's on the solution and what we offer side. And of course, if you look to the various countries that we are in, some are more challenging than others at the moment, and we're doing our best to cope with that.
Thank you. So this is another slicing question. What will be the main differences between slicing in 5G and 6G? Tommaso, do you have an idea?
Well, I can attempt an answer to this. I think slicing, the way it's been deployed, at least so far in 5G networks, is somewhat limited. It's for the most part based on core slicing. What I think will happen in next generation networks, I'm a little hesitant to call them 6G. I don't know exactly when this will happen, but is an end-to-end slicing. So slicing of functionality from the radio access network at the core and at the edge of the network. That's something that, you know, it's not done today, and will enable providing the resources that will be needed to provide advanced vertical integrated services, as well as create the level of isolation that is needed between the different virtualized networks.
Thank you. So next question is, we see some end users, like I believe Volkswagen, planning to connect 300 factories with 5G. Will the need for these connections and the traffic they generate between factories lead service providers to prioritize such 5G or 6G ecosystems?
Well, I think this please go ahead, Stephen.
Yeah, I think we talked about it. We talked about the little cluster. So each factory will be a cluster. So a lot of the idea of setting up these clusters is that you process the data, you know, local in the factory, and you don't end up transmitting a lot of data. What you'll be transmitting is a lot of data that you need for some of your diagnostic applications, AI applications that have, you know, that they're better served in the cloud. But I think you're going to have a lot of processing and a lot of the communication, especially the high bandwidth communication. It's all going to be done, you know, local, and only the data that needs to go outside and shared between the factories will be shared.
Patrick, did you have something to add?
No, I think I fully agree with that one. That it's about doing it the smart way and do local when you can, and then you know what will probably happen if Volkswagen would need a good connectivity between their sensor, they would ensure that they have private lines in between those.
Thank you. So here's more of a general question. Do you agree that all these projected services under 6G are high-end and maybe unaffordable for the common man?
This is I think an interesting question, because in any generation, and I think you get some surprises, right? And it might be anything from this VR glasses that are not glasses, or things are just integrated in your screen in your car or something where it's just there, and then the technology that has evolved will just make it possible. And then in those cases, it will certainly be for everybody. or you can get industrial uses that actually makes lives a lot more easier in various settings. So I don't expect everything to be a high end. I certainly do not hope so.
Same here, same here. It would be a shame if everything was out of everyone's price range. Does anyone else have anything to add with regard to that question?
Yeah, also agreeing. And in order for 6G, as we heard this morning from him, the why 6G, I think it's important to have that social angle, right? So not just the coverage, but also how does it impact accessibility, climate neutrality. So there are all lots of whys here. I think if you're looking back, the other 3 generations, iPhone was initially launched with 5G, 4G, for those with a taste for fancy features. So there will be a market for that, no doubt. But really to bring the value of 6G or 5G or all the wireless connectivity to everybody and everything, I think having that social perspective is really important in this vision definition stage. So it's the right time to really put more emphasis on that.
Thank you. Next question is, in the current scenarios of mobile operators deploying 5G networks, they're struggling to monetize. How different will it be in 6G? Does anyone have a crystal ball handy?
Yeah, that's what we're seeing. We're seeing the struggle, and since day one, what is the driver for 5G, and how are we going to pay for the trillions of dollars of deployment? And the carriers have been focused mainly on spectrum, buying the spectrum rights, and it was a question of who's gonna pay for from the data center perspective, all of these new MEC data centers and all of these RAN networks. What we're starting to see is, and I said it earlier, a little bit of a convergence of IT, and telco networks and data centers. So you're going to start seeing, like, I think, multifunction MEC data centers. So they're not only going to be telco specific the way they are now, but they may also be hosting some of your cloud services from the same MEC data center. So I think the carriers are focused mainly on the the spectrum, and they're counting on somebody else, whether it's a it's an internet giant or a large data center provider for rolling out the infrastructure to be able to support it, to be able to justify the return on investment.
Thank you, Stephen. We've got another. Patrick, did you have something to add?
Yeah, I think I'll just concur to that. That the answer to this lies in the way we're able to work in these partnerships, and the way we're able to slice some of the new business models, and yeah, that will actually, and how we are scaling between industries as well, and that we'll see in the coming year what is a success and what needs to be remodeled. It's not trivial, but it's really a lot of hard work with good partners.
Thank you, Patrick. And we've got another question for Sylvia specifically. Looking across members of the group, I'm assuming the 5G ACIA, what are the longer term directions that are not really yet articulated, but could be extrapolated to 5 years, 10 years, and particularly when this new college grads enter the workplace?
That's a good question, Caroline. And so I think this really points to the direction of skills, right? In terms of how the next generation can really be prepared when the new technology are deployed in the future, in this 5-year time or 10 years time frame. I think that's a very key question that at least I can share some experience from the UK here. I'm also from the UK 5G side. We have colleagues here actually looking closely on how we can encourage the young generations looking understand the direction of travel in terms of technology evolution and the exact skill sets, the gaps that need to be addressed in the future in curriculum as well. And there's also new initiatives to provide a platform and if you like, the practical sessions for teenagers to experience the kind of idea generation. How can they innovate in sort of technology environment to prepare them, to prepare the future workforce? This is a very big topic, but certainly a very important one. Need to be addressed now, and of course this is a collaboration not only between schools, but also industry, policymakers, and I think to really address that, we need a holistic approach, and it should be addressed now if we want to be prepared for the 6G, if you like, in the future.
Thank you, Sylvia. Next question. There may be doubts as to the ability of small enterprises to support the projected cloud services of the future unless they have a private cloud. Does anyone have any comments with regard to that assessment?
Yeah, I think we covered that a little bit with the cloud providers are extending their data center architecture and their services locally. So the enterprise will actually be able to bundle, if you will, some of the cloud services with some of the telco services. So it looks like the model is still developing and the partnerships are still being rolled out, but that's seems to be the way it's going to work. And a lot of the internet giants that are deploying these services locally are doing it as a service basis. So they're trying to come up with models that are affordable to all customers as they roll it out.
Thank you. Next question is, as we are just seeing the first commercial 5G services being rolled out, is it not a little dangerous to be putting 6G on the table? Could it not increase hesitation for verticals to adopt 5G?
Well, I can have a go at the beginning. I think, we know that there has been for a long time these 10-year cycles, and right now we're in what I call the fun part, where you set the vision. Yes, you start talking about the next generation while you're still rolling out the existing one, but what you really do then is to both stretch yourself and to, if needed, learn if there are any errors that you've already seen, or if you have imagined the improvements. So in theory, the answer is yes, but in practice, we need to do it to get the next generation even better.
Also, researchers and innovators like to live a dangerous life. So.
Thank you both. Next question is, how much of 6G will be about higher frequencies, for example, terahertz, versus targeted improvements, for example, new modulation schemes and waveforms, etc., on what can be done today in the sub-terahertz and below frequencies?
I can start, but there is not one answer to that at the current moment. You will have evolutions of all the various parts, the core part, the radio part, and of course we will have to work a lot more on the higher frequencies where we haven't worked before. And then it comes to what is the use. Sometimes the use is about flexibility or reliability, and sometimes the use is about extremely high capacity, and that will decide what you will focus on. So, and then, as Sylvia pointed out, the overall why are we doing this to improve society will also be hopefully quite clearly stated and quite a lot worked on over the coming years.
Thank you, Patrick.
And if I may add something, I think there will be a lot of certainly evolutionary improvements, but I think that there's space in the next generation for making some significant leaps forward in terms of going into higher frequency ranges in the area of spectrum sharing, right? Which is something that we're at the beginning, and there's a number of great opportunities, and also in the area of application of algorithmic developments and virtualization, as we discussed, for zero touch network configuration and automation. So I think this in my mind will be the three major areas where 6G will separate itself from 5G and what has come before.
Thank you, Tommaso. Next question is, what is the big problem that 6G will address beyond what will be addressed by the 3GPP releases that will come about toward the tail end of the so-called 5G era? Is it to figure out how to make ultra high frequency bands, terahertz, for example, usable?
Yeah, I can try this one. So in fact, this summer, 3GPP will have a workshop exactly discuss the vision of the direction for 6G. So it's good to keep an eye on. So it'll be August or September, that sort of time frame. But in terms of really what will be covered, I think that'll be quite a lot of stuff still. Depends on the vision, how that's been set. But one of the interesting feature, I think, will be quite fundamental enabler for quite a lot of things are the high precise time synchronization. And this one, we're not talking about microseconds, but really nanoseconds. So this will actually enable a lot of things like high precise positioning, synchronization between the networks, synchronization between devices, etc. So with that, you could cover or reduce the latency in some way. But in terms of general direction to travel, really this summer is a time frame to really get that holistic view from different stakeholders, if you want to follow that.
Thank you. Next question is, if communities, both if residential and industrial collectives in nature, turn to smart microgrids for power and communications, what impact will they have on macro grid business models?
That's a loaded question. I think from the power side, Schneider is very much involved with microgrids, less on the communication side, but we see a need for microgrids to supplement, and basically harmonize the electric delivery across the world. So, as battery technology, mainly for backup and supplemental power, but as battery technologies, hydrogen storage technologies improve, hydrogen production technologies as well, it may merge into, more of a longer term. So we do see, the move towards more localized power distribution. On the communication side, it's all being controlled, by these 5G networks, but I'm not aware of using the microgrids for communication as well as power delivery systems.
Thank you. This is another question for Sylvia. What are the main skills you see being needed to work with future 6G systems? Are they mostly around software and knowledge?
Well, that's a good question, and it can take days to answer, but let me keep it short. So being actually working in the ICT and telecom industry for 14 years, what I see is a holistic skill set that needed to advance not just 6G, but the whole industry really. So soft skill, that's important. Essentially, that the STEM the subjects, depending on which the level of the grades we're talking about. The STEM subject, that's important, get that fundamental entrance tickets, if you like, to this industry. But also, I think it's really important to have that creativity, innovation, because really, once we built, at my generation, build this infrastructure, regardless it's 5G or 6G, we need people to actually create application on top of it to really create this positive impact to the society we've been talking about. So we need people with creative idea generating new business cases. So it's not just about technical skill set, but also business side knowledge to really understand how to monetize the technology and what is working and what is not working. So it's a combination, holistic really. So the whole industry need everybody, different skill set to really make the whole system thrive really.
Thank you. And we actually got a bit of a follow-up for you. Is it possible for you to provide any information about forthcoming meetings and possibilities for participation?
Is it the 5G ACIA? So if it's a 5G ACIA alliances, so certainly you're welcome to have a look on the website. We will have webinars covering technical aspect, but also the test beds that's recently approved in the industrial domain using 5G. So that's also could showcase what has been done, what has been successful. I will type a website address in this chat box later in a second, but there are, have a look on the website, that should be all there.
Thank you. So another question, do you see engagement from giant software companies in, for example, Google, Amazon, Microsoft, in developing applications for 5G and 6G?
I can start with that one. I think here we're back to the edge that Stephen particularly talked about, and how the the various cloud solutions will integrate with edges going forward.
Awesome.
So there is certainly an engagement, and those are among the partners that needs to be part of this total solution.
Yeah, you see Amazon in particular with their fulfillment centers bringing in 5G as part of their automation for the picking and all of the communication between their sites and their networks for delivery systems, and that's going to integrate into drone delivery systems that we showed earlier. Possibly, we're still working out the air rights and things like that. But and Microsoft with their immersive experience they have made a lot of progress in advancing technology to bring immersive experience more to life, and including more of the sensing that we talked about earlier.
Does anyone have anything to add? Okay, I've got another one of my questions before we wind things down. We've talked a lot about individual verticals. Where do you see cross-industry communications headed? Sylvia, would you like to take that?
Yeah, thanks, Ryan. That's a very good question. Actually, there are a couple of activities ongoing, which I think we can use that as a good practice, if you like. One is the 5G Vertical Users Workshop, which was organized by 5G Infrastructure Association. I think they also have a session tomorrow morning. To shout out to them. So it has organized 3 sessions, 3 workshops, and brought together 5G ACIA, 5G AA for the automotive industry, vertical 3GPP and satellite vertical utility and health sector and media sector to really share the learnings and address the key pain points I'd like to incorporate into the standardization process. So that's a great way to encourage dialogue between different industries in a single forum. The second one is, at least in the UK, we have UK 5G. We have 6 working groups covering manufacturing, media, creative industry, green energy as well, recently opened one. and security. So I think through these groups, we managed to cross kind of enable that cross communication between the demand side, supply side, but also cross industry communication as well. So that has been working really well. So you can have a also look at the website UK 5G. The third one I think is interesting example is to leverage EU projects, EC projects, European Commission projects. We've seen in the past, most of the European Commission projects are designed to specifically to a dedicated vertical, but perhaps in the future, we could encourage one single project, but invite different verticals. So once they're working, towards that one framework, literally they provide a condition for cross-sector communication, but also a way to find a synergy between those cross-sector. And I think that could potentially be an interesting way to create that condition to further advance that communication channels.
Thank you. And with that, we're approaching the end of the discussion. As time winds down, I'd like to give each panelist a chance for one final thought. What do you predict will be the technological development shaping the next decade to the greatest degree from a network operations standpoint? Stephen, would you like to start us off?
Yes, thank you. I think the technological advancement is going to be along, from a data center perspective, the ability to design and deploy these data centers to be located anywhere. So I think a technological example would be, some kind of, alternative power system, so they make it fast and easy to deploy these, like I said, in these applications, tops of buildings, parking lots, car parks. So I think you're going to see some things coming to be able to easily deploy them and really simplify the deployment of 5G and 6G in the future.
Thank you. Tommaso, same question.
Yeah, I think in my mind, the main innovation will be the reliance on network automation and the nexus between softwareization, virtualization, and algorithmic development that will really change the way networks are operated and optimized.
Thank you. Sylvia.
Instead of predict, I like to actually have a wish list for the industry, really to look at the green transition, because network operators, network infrastructures, they are consuming around 2 to 3% of the global energy, according to GSMA. So if we can really bring that number down into a sensible one, I think that's a really great contribution to these sustainability goals. And for that to happen, I think it needs everybody contributions. I think that wish list hopefully will be providing input to the future technology discussion.
Awesome. Patrick, I guess you've got the final word for 30 seconds.
That's excellent. Well, thank you. I really agree with the green part, and I do think that the degree of network automation that we will see going forward will drive us towards AI-driven networks, and that will be the one technology development that will help us both in the green direction and for more efficient networks. So that will be my final word. Thank you.
Perfect. So I'd just personally like to take the opportunity to thank Patrick, Stephen, Sylvia, and Tommaso for joining us and sharing their thoughts. So thank you all. Remember, to our audience members, if you want to see the webinar recording, it will be available at www.6gworld.com in a few days' time, along with plenty more great material. If you have questions, comments, or suggestions, feel free to get in touch with us through the site. We'd, of course, love to hear from you. Thank you for joining us today, and hope to see you again soon.